Hey everybody, lesson 8.5, section 8.5, the law of sines. Plain and simple, that's our objective, that's our vocab. Let's find out what it is. Alright, for the first time, we are branching out. We are actually going to learn a technique that works for any triangle. Everything we've done in this chapter so far has worked only with right triangles. Pythagorean theorem, 30-60-90s, 45-45-90s, and sine, cosine, and tangent ratios up to this point have only worked with right triangles. For the first time ever, we are at a point where we are going to learn something that applies to any triangle. Does not have to be a right triangle. All right. So here it comes. Before we get into it, I want you to see the designation for the triangle that we have here. We're going to be using this a lot in the next two chapters. I'm going to label the angles as capital A, capital B, capital C, and label the sides with little letters. But it's incredibly important that you recognize that little letter side A is opposite angle A, and side B is opposite angle B, and side C is opposite angle C. All right, really important that we draw that conclusion here. Okay, we're labeling the sides opposite the angles. Everybody see how that works? We're going to do that in these next two sections, and it's very, very, very important. All right, so side A, opposite angle A, etc. Now, look what happens. We're going to draw just any random triangle, and we're going to drop an altitude from angle B down to the opposite side, to side AC. And check it out now. Look what we've got here. We know that the sine of angle A is opposite over hypotenuse. Well, here's the opposite in this left-hand triangle, and here's the hypotenuse. So the sine of angle A has to be x over c. See it? Meanwhile, the sine of angle C has to be opposite over its hypotenuse for this other triangle. That's x over A. Now, doing a little mathematical wrangling, I can multiply this equation by C in order to get x by itself. See how we're doing it there? And the second equation I can multiply by A in order to get x by itself. And once I have x by itself from those two equations, I know that what they're equal to must be equal to each other. These are both equal to x. That's using the transitive property, right? So we get ourselves to this point right here, after which we do a little bit more wrangling with our math. We're basically going to divide both of these by C and by A, and you look what comes out. That the sine of A divided by side A, the length of side A, the ratio of those, is equal to the ratio of the sine of C to the length of side C. Now, digest that for just a second, because you know what? We're going to do it again. Only this time I'm taking the same triangle, drawing a different altitude. So I'm drawing the altitude here instead of the one we were working with last time. But we're going to do the same magic. The sine of A is equal to opposite over hypotenuse. Whoops, I wrote that wrong. Let me erase that. Opposite over hypotenuse, so it's y over b, right? Meanwhile, angle B, the sine of B, is opposite over its hypotenuse, so that's y over a. Now, rearranging, I'm going to multiply this by b, so y gets by itself, multiply this by a, so y gets by itself, set those things equal to each other, do a little more dividing, and this time I find out that the sine of A equals the sine of B. But a page back we found out that the sine of, oh boy, I just said that really bad. Try again. Here, this page, we just find out that the sine of A over side A, the length of side A, is equal to the sine of B over the length of B. A page ago, a page back, we found out that the sine of A over side A equaled the sine of C over side C. And look, they're all equal to each other again. Therefore, the law of sines says that the sine of A over the length of side A is in the same proportion as the sine of B over the length of B and is equal to the sine of C over the length of C. All right, really, really important. We're going to be using this a lot. The sine of angle A over its opposite side length is equal to the sine of B over its opposite side length is equal to the sine of C over its opposite side length. There's the law of sines. All right, so how do we use them? We use them to solve triangles that are not necessarily even right triangles. Okay, we need to know two things. All right, we need to know three pieces of information, like either two angles and a side or two sides and an angle. And to use the law of sines, one of the sides we know must be opposite one of the angles we know. Critically important. We must have an angle and a side, know both of those. Now it could be A, it could be B, it could be C, but we must know that one angle that's given to us and one side length that's given to us. We got to know one of each of those to use the law of sines. Check out how it works. So here's your description. In triangle ABC, it gives you the measure of angle A, measure of angle B, and the length of side AC. So find the length of BC is our task. I'm going to give you a second to pause if you want to try this on your own. Now I do realize this is your first one, so I wouldn't be surprised if you just want to wait for me, but here we go. Here's how we're going to do this problem. All right, so I'm first going to draw a picture of my triangle. Everybody see the picture here? And I'm going to label measure of angle A, 48 degrees. Measure of angle B, 93 degrees. And don't worry about whether your picture is accurate. It's just to get a view of what you're seeing here, okay? Side AC is 15 degrees. So we've met the criteria for the law of sines. I have three pieces of information, and one of them involves an angle and a side opposite it. So I can set up the law of sines by saying that the sine of 93 is to the side opposite from it, as the sine of 98 is to the side opposite it, which is BC, which is what we're looking for. Sine of the angle over the length of the side is equal to sine of the angle over the length of the opposite side. There's the law of sines in action. Cover that. Okay, so once we have those numbers, we plug in the values from our calculators. Sine of 93 is that. Sine of 48 is that. We cross multiply and we divide and we find out that BC is going to be 11.16. Now notice actually we could even keep going on. I mean we can go ahead and find side AB if we wanted using the law of sines. Okay, right? Because now we realize that this angle has to be 39. So we could also set it up, sine of 93 over 15 equals a sine of 39 over side AB over its opposite side, and be able to do that same way we did over here. Basically set up a ratio, cross multiply, divide, following the law of sines. If the sine of an angle over its opposite side equals the sine of another angle over its opposite side. I'm hoping that's coming clear. Another example coming, one for you to try on your own. Pause if you like. Here comes the answer. This one's going to be a little bit different because we gave you, instead of a side angle side, we gave you an angle with two sides. All right? But we did still give you one angle and the side opposite from it. All right? So I can do the law of sines because I have an angle L and the side that's opposite from it. So we set it up. The sine of 105 is to 14, as the sine of k is to the side opposite it, 9. We plug in the sine of 105 from our calculator. We're going to multiply both sides by 9 to make that cancel. And we end up right here. Simplify. Now, once we're here, remember we can find the angle K by taking the inverse sine of 0.6210. We find that angle K must be 38.14. Okay. Now, problem didn't ask us for angle K, it asked us for angle M, right? But now that we have K, we know we can find the angle M, because we need that third angle plus this one to add up to 180. So that's the way I would do those problems. One last problem example coming up. Alright, so word problem. It's a softball problem, so one of my favorites. Got a right fielder, and read the problem, give it a try. Here comes the answer. Pause if you like. Alright, so let's call this distance from the right fielder to second base. Let's call it X. Use a color different than green. Okay, so let's call that distance there X. Alright, let's also remember that if this is 68, this is 40, they have to add up to 180. That's got to be 72. Alright, now using the law of sines, the sine of 72 over 60, right, angle opposite side, must equal the sine of 40 over its opposite side. Check, check. Cross multiply, divide, we find what X is. If you have any questions, I will talk to you. Come on and find me, and we'll get these solved. But I hope this all makes sense. We'll see you later.